Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. In this video tutorial, we will discuss a problem on the motion of a horizontal spring block system asked by a student. The question is as follows. A block of mass m lying on a smooth horizontal surface is attached to a spring of negligible mass and spring constant k. The other end of the spring is fixed as shown in the figure. The block is at rest in its equilibrium position. Now the block is pulled by a constant force F towards right. Then answer the following. Question 1. The maximum speed of the block is. The options are F divided by pi root mk, pi f divided by root over mk, f divided by root over mk, and 2f divided by root over mk. Question 2. The maximum elongation of the spring is. The options are 2f by 3k, f by k, 3f by 2k, and 2f by k. Before solving the problems, let us analyze the physical quantities which will undergo change, which will lead us to find the maximum speed of the block and maximum elongation of the spring. Initially, the spring is relaxed, which implies spring force is equal to 0. Constant force F is applied to the block. Therefore, net force on the block is equal to F towards right. Due to force F, the block will be accelerated towards right. As the block moves to right, the following quantities will change. There will be elongation in the spring, which will go on increasing. Due to this, the spring force will also increase. It will act in a direction opposite to the applied force F. At any displacement x of the block, the spring force is equal to kx towards left. Therefore, the net force on the block is F minus kx. As x increases, the net force will decrease gradually. Therefore, for some value of x, the net force on the block becomes 0. Let x is equal to x0, where the net force becomes 0. As x increases beyond x0, spring force to left becomes greater than applied force F. Therefore, the net force is towards left. Hence, the block will go into retardation. This implies that speed of the block is maximum at x is equal to x0 and it decreases beyond that. Therefore, finally, the velocity of the block becomes 0 and it stops. Therefore, for this value of x, spring elongation is maximum. Now, let us solve the problem in question 1. Initially, the block is at rest. We consider it to be the origin where x is equal to 0. The spring is in relaxed state, hence spring force is 0. The only force on the block is F. Therefore, net force on it is equal to F, which acts towards right. The block is accelerated towards right due to F. Therefore, for any displacement x, the spring force increases to kx, which acts towards left. Therefore, the net force on the block is equal to F minus kx. The spring force increases constantly, hence the net force decreases, and for some displacement x is equal to x0, net force becomes 0. Therefore, we have F minus kx0 is equal to 0, which implies F is equal to kx0. The kinetic energy of the block is maximum in this position. We need to determine the maximum speed of the block, which is at x is equal to x0. From work energy theorem, we have work done by the net force is equal to the gain in kinetic energy of the block. Since initial kinetic energy is equal to 0, this work gives us the maximum kinetic energy of the block, which in turn will give us the maximum speed of the block. Now, work done W is equal to integral of F minus kx into dx between limits x is equal to 0 to x is equal to x0, which gives W is equal to fx0 minus half kx0 square. Putting f is equal to kx0, we get W is equal to half kx0 square. Therefore, we have half mv max square is equal to half kx0 square. Therefore, v max square is equal to kx0 square divided by m. Putting x0 is equal to f divided by k, we get v max square is equal to f square divided by mk, which gives v max is equal to f divided by root over mk, which is the answer to question 1. Therefore, the correct option is C. Now, let us solve question 2. In the figure, initial position is equal to A. O is the position where velocity is maximum and net force is 0. Beyond O, spring force becomes greater than F. Net force is towards left and the block moves under a retarding net force. Let the block come to rest at B. Let x is equal to x dash at B. Therefore, from A to B, change in kinetic energy is equal to 0. Therefore, total work done is equal to 0. Now, work done by F from A to B is equal to Fx dash, and work done by spring force is equal to minus half kx dash square. It is negative because force acts opposite to displacement. Therefore, W is equal to 0 implies minus half kx dash square plus fx dash is equal to 0, which implies x dash into f minus half kx dash is equal to 0, which implies either x dash is equal to 0 or f minus half kx dash is equal to 0. We ignore x dash is equal to 0 as it corresponds to the initial position. Therefore, f minus half kx dash is equal to 0. This implies x dash is equal to 2f by k. which is the answer to question 2. Therefore, the correct option is D. This completes the answer to the questions. If the video is helpful, then please like and subscribe.